Hello and welcome to this Mechanical Joint Integrity, the State of the Nation event from the Institution of Mechanical Engineers Process Industries Division. I will start the event very shortly. I will give people about a couple of minutes or so at most so that they get to join. And thank you all very much again. Just bear with us for a few minutes. Thank you. Chris, I'm gonna introduce the event, introduce yourself right now. Chris Mellows is a director of Zulu Joint Integrity and Training Limited. He is a member of the IMechE's Process Industries Division Board and also a member of our Education and Skills Strategy Board. I also need to highlight, I guess this is the first of the series of an event we will call probably the State of the World. Just to give you an idea on the number of people that we expect today, there should be about 100 people attending today. That's why I was cautious to wait a little bit here. There are 163 people actually registered today, so there is definitely a great interest for the event. Chris, if you could move on to the next slide for me, just to do some housekeeping, I guess. The event is being recorded. It will be made available on our YouTube playlist. We disabled all the attendee media to allow for a smoother presentation, of course. You can obviously submit your questions through the chat function or the Q&A tab available to you. We will try to answer as many of them as possible at the final last 10-15 minutes time. Chris was also happy to share the slides at the end, so please focus on what he is talking about rather than trying to take screenshots. And I'd like to have a great, enjoyable session. Chris, please take it away. Thank you so much again.
Okay, thank you, Murat. As Murat explained there, this is hopefully the first in a series of webinars, looking specifically at mechanical joint integrity and the issues and concerns that we are finding and have been finding for many years now in our process industries. I hope you find the presentation of interest. So the way in which I've set this out is I'll do a quick introduction, just going on from Murat. Just going to look at the current state of mechanical competency in the UK. I'm going to be sharing some data, some statistics, lots of photographs and things that we find out in industry. I'm going to look specifically at the current mechanical joint integrity standards, the guidelines, the compliance documentation that is readily available for our process industries. I'm specifically then going to look at the industry approved mechanical joint integrity training standards and qualifications for those that are responsible for making, breaking containment and remaking bolted flange joints. And then, look at the future, because there is a future. And then I'm going to summarize and hopefully we'll have a Q&A session at the end. So just a little bit about me, just going on from what Murat said. I'm the founder and director of Zulu Joint Integrity and Training Limited. Initially started the business 15 years ago, actually, this December. I'm involved in IMechE for the last 2 years, I think, maybe 3 years. I'm part of the Process Industries Division Board member and the Education Skills Strategy Board as well. I'm a board member of that, which is very interesting because we are looking at the subject of mechanical engineering throughout the UK, from school level, with STEM, etc., through to apprenticeships and the existing sort of workforce that we have in industry. My background, I'm a time-served engineer and apprentice. For those of you that remember the days of BP Chemicals, I'm a fitter and turner by trade and came through the apprenticeship route about 34 years ago. I've got a lot of experience in the oil and gas, petrochemical and chemical industries, specifically looking at hydrofluoric alkylation units on oil refineries, specifically for joint integrity and flange inspection. So that'll give you an idea of like who I am and a bit about my background. The business, so Zula Joint Integrity, we are a joint integrity compliance and training company, basically. We help support UK industry and further afield. We actually operate overseas now as well. We look specifically at COMAH registered assets. We carry out compliance audits where we benchmark against the current standards and guidelines in terms of mechanical joint integrity. So that's looking at the joint integrity process on site, not just training qualifications, but things like record keeping, using controlled methods of bolting, for example, joint integrity tagging, and all other things that are certainly mentioned within the current industry guidelines and standards. We carry out flange inspection services, flange management, QA, QC for projects and turnarounds, and we've got some clients where we've got a permanent site presence. We also deliver specifically joint integrity training and assessment qualifications and courses, and I'll mention that in a little bit more detail as we come on to that part of the webinar. There's a bit of an in-joke actually with us at the moment that we always seem to be beating the drum for compliance, and that's what we do as a business. I'm very passionate about the subject matter. Our business is very passionate about the issues and concerns that we are finding in industry, and it is that passion that really does drive us, and allows me to speak on a platform such as IMechE to yourselves about this very serious and often overlooked subject matter. We really do have to look at the current state of mechanical competency, and if there are any members who are present today in a turnaround role or maintenance role, you will no doubt have felt the pain during a turnaround event, etc. We need to determine where our current process industries sit, and we have to understand the current state of mechanical competency. So if we look sort of as a snapshot of history, if you like, and we are where we are kind of thing, we have had certainly a lack of apprenticeships over the last, well, I would say probably 30 years across the board. And I'm honing in specifically on mechanical engineering apprentices. And that certainly has affected where we sit right now. We have a lot of chances, I'm going to say, in our industry. And yes, they've always been there in some shape or form. But we are, particularly over the last 2 to 3 years, are seeing a very high level of bad workmanship, incompetencies. And when you investigate the personnel, perhaps, that have been responsible for loss of containment, for example, they are not who they say they are. So it's therefore very important that the checks and balances are put into place to ensure that the right people, and it's very difficult at the moment, I understand, because the labour pool is so saturated with these people. But we are seeing a worrying amount of chances in our industry. We have an ageing workforce, and I'm not here to be ageist in any shape or form. But these people who no doubt have got a lot of industry experience, when they are retiring, we just don't have the younger element coming through to replace them. COVID actually really did hit industry. In fact, the demographic, if you look at people between the age of 50 and 60, were deciding post-COVID that they wanted to sort of retire early. So it really did leave quite a gaping hole in our current industry. Historically, there's been a shift towards academic education, and obviously there's a requirement and a need for that. But it seems that over the last 20 odd years plus, there's generally been a feel for, young people to go to university to do a degree. Doesn't really matter what kind of degree that is. And therefore that has affected the apprenticeship sort of scenario. Yes, there's been economic changes. I remember when I was an apprentice, when I started in 1990, there were 12 oil refineries in the UK. So that'll give you an idea of, the way in which our industry has changed over the last 30 years. However, there are still a sizable amount, hundreds upon hundreds of COMAH registered sites within the UK. And so, our process industries are certainly still buoyant, I would say. And we have to acknowledge the fact that, there are going to be, and there are currently, some massive nuclear projects within the UK. And I will mention, the likes of Hinkley Point C, that seems to be, kind of sucking the life out of our existing industries. There seems to be an exodus of personnel within UK industries wanting to get onto that project. And I think it's safe to say that we are all feeling the pinch of that throughout all the corners of the UK currently. So that, it's like the perfect recipe for, I'm not going to say disaster, but it's the perfect recipe for the position that we're in right now, particularly in terms of competency levels. As it's coming up to Halloween, I thought I'd put together a bit of a chamber of horrors. We've literally got 15 years worth of photographs and evidence of bad things that we continue to see in industry when we are carrying out our compliance audits and flange inspection programs, etc. So here's just a snapshot of typical things that we find. A bugbear of mine would be boat length, for example. Standards that are out there, and most sites stipulate that certain boat lengths should be a minimum of 2 to 3 threads. We don't accept anything, and we are seeing an increasingly number of these across our sites. Nuts on the back, on the reverse, on the wrong way round. And of course, there are varying levels of what we're going to say are short bolts. And that's probably one of the worst I've seen. And by the way, these are all photographs on upper tier COMAH sites within the UK, and this is just the tip of the iceberg. Radial misalignment, parallel misalignment, we still see a significant amount of these on site. And as you can see from that photograph, that flange has been sort of left in situ like that for some time without anybody addressing it. We are just going through some turnaround events in the UK, and we look at collecting data during those turnarounds, and it's still evident to see that misalignment is certainly one of the top problems that we are finding, particularly in the chemical industry, where there are soft gaskets used, for example, with the sort of PTFE envelope gaskets, etc. We see a mixture of things like, incorrect bolt materials being used, dissimilar materials, incorrect bolt length, incorrect bolt, including the diameter of the bolt, for example. We still see a lot of this on site. Corrosion is a massive problem also in the UK. Our sites are getting older, obviously, and maintenance is key, as we all know. However, we still continue to see plant and equipment in this state. Underlagging, corrosion is still a big problem and concern, and always seems to have been, but it really is exaggerated right now. We see a lot of issues relating to things like loose bolts, and I mean sort of finger loose. You can move the nut on the thread. Likewise, we see a lot of over torqued bolts on flanges because of the bolts are being sort of flogged up and gunned up using unconventional old methods rather than a controlled method such as using a torque wrench, etc. So therefore bolts are being put into yield, Particularly soft gaskets like this one, you know, PTFE envelope gasket, have been absolutely destroyed because the tightness of that flange is based on somebody's interpretation by hitting a spanner, for example, or pulling up on something rather than using a control method such as a calibrated torque wrench. So, you know, soft materials don't really stand much of a chance, really. And we're still seeing a high level of these on chemical sites, even though the chemical site actually uses torque wrenches and they give out torque data to the personnel and to the contractors. But there is a human factor here as well, and that factor is that people like to, you know, just pull up a little bit more, or just to make sure everything is kind of, you know, tight enough, I guess, in their mind. You know, we encourage people to, you know, stick to those torque figures that they're given and never exceed them, for example. We do still see, you know, 2 gaskets back to back. On the off chance we will see something like this where you've got 3 gaskets. The maximum we've seen is 5 spiral wound gaskets, all back to back. You know, generally, if something doesn't look that good, it probably isn't that good, and that's definitely a trait, you know, when out in the field looking at the state of a plant where we've got you know, incorrect diameter bolts, etc. Double nutting, you know, we still see that now and again. Cutting gaskets, I'm sure you're all familiar. You might have seen something similar where, you know, the rule of thumb is the only gasket you cut is sheet gasket with a gasket cutter. You never alter the design of a gasket, but we're still seeing a lot of spiral wound gaskets that have been cut to size. Loose bolts, no bolts. And just when you think you've seen it all, about 4 or 5 years ago, we came across 2 separate sites in the UK, both within the chemical industry. One was a brand new 20-bar steam system project where we found, I think it was 5 or 6 slitting discs used as gaskets. And this particular one from another chemical plant that had obviously been in situ for some time and was leaking. I mean, that goes beyond somebody's rational sort of thought of using a sealing element within a bolted joint. And that's the problems that we are still facing, unfortunately. I mentioned earlier on that we collect a lot of data, and data is a powerful method of really seeing the state of the plant, if you like, at the work face. So, for example, if you already use existing, you know, joint integrity program whereby you record the amount of flanges that have been, you know, perhaps looked at during a turnaround event. As long as all the data is there, you can really dig down quite deep and find, you know, trends, for example, and see things that might be affected by perhaps the competency of the people on site. What's interesting for me right now is that some of the turnaround events that we're doing, I've looked at the collective data, and we categorize our defects, if you like, that we find out on site, simply 1, 2, and 3. 3 being the worst, such as, you know, no gasket, wrong size gasket, loose bolts, that kind of stuff. Things that would, you know, ultimately result in loss of primary containment, for example. And unfortunately, category 2 and 3 make up about 50% of all our findings currently. And currently, we are looking at probably in excess of 6,000 to 7,000 bolted joints that we've inspected. That is a worry. Earlier on this year in April, there was a bolted joint seminar with IMechE in Newcastle, and it was a very popular event, and that's what really sort of started this off, really. And at the time, I was giving a very similar kind of talk during that seminar, and as part of my preparation, I did this, and this data, this is very interesting, I think, because this data relates to our business, my business, in terms of flange inspection. And I've gone back on data that starts back in 2010, right up to 2023. And the green bars that you can see there are basically the numbers of bolted joints that we inspect on turnarounds and projects and things like that. And the red bars are the number of defects that we find. And what I've done is I filtered out all the kind of insignificant defects and just left in the bad stuff, you know. And the black bars, sorry, the black boxes that you can see there is a sort of percentage defect. Now, what's interesting to me is that the green bars are kind of getting more as the years go by, because hopefully our business is growing and we get more work. But sadly, the percentage defects are also increasing. And if you look at 2023, for example, we inspected nearly 12,000 bolted flange joints. That's either physically inspecting flange face conditions before the flanges are made, or physically looking at the made bolted joint. We torque check, we load check every single nut and bolt. That's quite a lot of work there, But to have almost 14% of all those inspections fail inspection because of loose bolts, over torqued, wrong gasket, wrong size gasket, wrong type gasket, no gasket, slit in disc. It's that is a big concern. It's a big worry, and I'm more than happy to share this, because this is just us, by the way. We're a relatively small medium business. It'd be interesting to see what other people are finding, I think, on their assets and so forth. So I just wanted to share that with you. And also, for those of you that are involved in sort of, particularly on turnaround events, for us in sort of like a QA role and inspection, again, we can look back historically, and there's a definite, what we call it, an M curve, relating to the spikes, if you like, of defects that are found typically on a turnaround event. So if you take like perhaps a 7-week event, as you can see there, as time sort of moves on during the event, week 1 and 2 are relatively quiet because plant is being taken apart, pipe work is being, flanges are being opened up, etc. And initially, we always find when the plant and equipment is going back together, there's an initial spike of defects that are found. And typically, the asset owner will either have some sort of stand down or toolbox talk or whatever it might be, and encourage everyone, listen, let's stay focused on this. Let's look at best practice and so forth. And by the next week, things are really kind of dropping back down again. We do not see, even though the work is being carried out, we do not see that level of defects. And time kind of moves on. And then roughly about sort of, certainly the back end, I'm just going to say week 6 on this particular event, we see a definite second spike. And that second spike relates to the transient workers on site, the contractors that are working on site, when they are given their notice period during the turnaround event. And at that point, their interest, I guess, is, what's my next job? Where am I going to be working, etc. And they really take their mind off the job in hand. And we definitely see this this particular M curve. So it's interesting for me. And we've gone back probably over the last sort of 6 or 7 years, and definitely you can see a trend there, The cost of a leak, well, there is a cost to everything. Obviously, there's a cost to a fatality. There's a cost to any type of accident, environmental incident, etc. The visible costs. I'm sure you might have seen something like this similar in the past, maybe. But the visible costs. You see the loss of product. You see the steam leak, the water that's dripping from that flange that nobody ever bothers with, but then we look at what we call the invisible costs, which are astronomical, actually. The labor to repair leaks, the material, the plant inefficiency, the environmental fines, the lost sales due to poor image. No company wants to be on headline news for all the wrong reasons, that's for sure. And I often get asked, sadly, and it does still amaze me, that I speak to organisations that are either upper or lower tier COMAH site that don't have a recognised joint integrity process or procedure, and they ask me to come to site to give them a talk on what's required, etc., and whether we can sort of support them going forward. And it surprises me how many people actually say, well, how much is this going to cost then, to do this? And I find that sort of a little bit disturbing and sad, actually, because what we do find is generally when things are done correctly, that will significantly, reduce the possibility of a loss of containment and worse, obviously. Before I come on to the specifics of the training requirements, I just want to look at the standards and the guidelines and the compliance that's available right now in industry. Specifically, putting COMAH to one side, specifically, there are two standards and guidelines that are very, very important to our process industries. I just want to briefly kind of go through them, really. The first one is the current 3rd edition of the Energy Institute guidelines for management of integrity of bolted joints in pressurized systems. The Energy Institute obviously is the chartered professional membership body for the energy industry in the UK. This particular document describes the principles and good practice for the establishment of a management system for bolted joints in pressurized systems. It's an excellent document. As far as I know, the Health and Safety Executive partly wrote this document. They were certainly involved with it in its early days. And I know that the Health and Safety Executive, through their communications, particularly during this seminar that we had, was speaking very highly of this this guideline and what's contained within the guideline. I'm really going to sort of dampen it down a bit and say it's a dummies guide. I'm sorry, that's probably the wrong word, but if an asset doesn't have anything in terms of mechanical joint integrity, and that's looking at the whole sort of subject of it, then this really is an absolute fantastic document to read and to follow. As a business, we encourage our clients to follow this guideline, and I'm happy to say that lots of them do. And it covers pretty much anything and everything from theory of mechanical joint integrity, integrity testing, hot bolting procedures, records and data management. It covers everything and anything to do with mechanical joint integrity, tagging, for example, criticality rating of flanges. And very importantly, it looks specifically on training and competency. So in section 5, for example, there is clear guidance on what qualifications your personnel or contractor personnel should have in terms of mechanical joint integrity. Now, if you're like me of a certain age, you remember that once upon a time, there were no specific qualifications for mechanical joint integrity. It was the apprenticeship route, the ONC, the HNC, the City and Guilds, and it was all about learning on the job from your peers, etc. And what I will say is that the offshore industry, for example, has really championed the training and competencies required, if you like, probably for the last 25, 30 years, maybe. And it's good to see that being sort of disseminated throughout our downstream sort of, process industries. Specifically, it looks at ECITB, MJI, TMJI training standards, ASME PCC1 2022, BS, or sometimes just referred to EN 5091, Part 4. And I'll go into greater detail on it, but it says in there in black and white, these are and bearing in mind the Health and Safety Executive were involved in this, they are kind of telling you that, if I were you, I would get your guys and girls, trained to these standards. The other document, which is it's a standard, very powerful standard, which we are seeing many changes within the UK industry over the last 2 years, is the current ASME PCC1 2022, and in particular Appendix A, which refers to the training requirements. The ASME PCC1 traditionally was a guideline, and a very good guideline at that, and lots of companies would take elements of that to be used within their existing joint integrity programs and their policies and procedures, etc. But in 2022, it became elevated to a standard within itself, and we've seen quite a shift change. I can't mention any names, but there are 2 oil refineries that come to mind in the UK that specifically look at ASME PC1 2022 as their guidance specifically for onboarding of contractors, for example, in terms of competency levels. And just moving on to competency, according to the HSE, the true definition of competency is the ability to undertake responsibilities and perform activities to a recognized standard on a regular basis. And the big difference between training and competency is that, people can be trained to do a task, but to be competent in something is completely different, because competency is based on a number of things, including your qualifications, your skills, your knowledge, and your experience. That's the key thing here. Just because somebody goes on a joint integrity training course for a day or a week doesn't make them competent. Absolutely doesn't make them competent. So what do we have? Well, the three main sort of training qualifications, etc., are the following. We've got the Engineering Construction Industry Training Board. We have the American Society of Mechanical Engineers, and we've got the British Standards also. So let's just take a little bit more detail on these. So ECITB, for example, you might be familiar with this. Mechanical joint integrity and technical mechanical joint integrity training standards, also known as MJI or TMJI, are standards that have, if you look at the history of them, derived from the UK offshore industry. And this is all to do with hand-torqued, flanged and clamp connector pipe joints. There are variations. So, for example, MJI 10 is the use of hand torque wrenches. MJI 19 is hydraulic torquing. MJI 18 is tensioning of bolts. And there are technical tests involved in this thereafter the initial. What I like about this, actually, there is a definite route to competency. It's not just about turning up and doing 1 day's training course or 3 days training course. You have to prove competency. So they've developed a clear route that also involves recording on site, a bit like an NVQ, I guess, of work that you're doing, particularly making bolted joints, and having a supervisor to sign that to say, yes, I agree that, Chris was working on those flanges on that date, etc. And then you have to come back and do a technical test. And what people don't realize is that if they do not do the technical test, the initial certificate will expire after 12 months. But by passing the technical test, that takes it out to a 3-year period. The standard is a prerequisite for working within the UK offshore industry. It now has global accreditation. You might well see on perhaps LinkedIn, for example, there are companies now in Malaysia and further afield in the Middle East who are developing and delivering ECITB joint integrity qualifications. The second one, well, as I mentioned earlier on, ASME, big changer, in 2022 when it became a standard. The bolting specialist qualification program is split into 3 distinct areas: fundamentals, bolting assembler, and the inspection sort of element. Fundamentals are for those who are new to industry. For apprentices, for example, it looks at the fundamentals of mechanical joint integrity. The bolting assembler is geared up towards the person who's responsible for remaking that bolted joint. And if you are involved in a QA or flange inspection sort of role, then the third one would be the choice of course for you, really. EN 1591, also known as BS EN 1591, Part 4. Again, this is proving to be a very popular training course. This course provides the knowledge, the practical skills required for disassembly and reassembly of bolted flange connections. What I will say is that all 3 courses are very much hands-on. It's not just in the classroom, and there are tests. There's a theory test, there's a practical assessment, and it is possible to fail these courses. Now, for anyone that's been involved in COMAH, it can be a headache. Obviously, it's very, very important to us. It's a regulatory, it's a regulation that's used throughout the UK industry. But clearly, as you can see there should be measures to protect maintaining integrity of pipework, integrity of bolted flange joints, etc. With all this in mind, I've come up with this kind of theory, if you like, that there is certainly a joint integrity paradox that we are seeing within our process industries. So, for example, if COMAH sites are highly regulated, which we know they are, if the industry guidelines and the standards are available, if people are attending recognised training courses, then why do we continue to see so many non-conformances and defects to bolted joint assemblies? It doesn't really kind of make sense. And as a snapshot, and I've taken this from some data from ECITB, if you look at the number of people that are attending MGI courses with ECITB from 2012 to 2019, there's a sizable amount of people that are attending these courses and carrying out the tests, for example. So what are the possible reasons for this paradox then? Well, from my experience, and I've been doing this for 15 years as a business, and as I said, I'm 34 years in industry. What I would say is that some, not all obviously, but some asset owners are not complying to regulations and industry guidelines. Some are complying, but they are not taking the subject seriously enough. Obviously, as I said earlier on, there's been a lack of apprenticeships, since the late 80s and early 1990s. That's affecting the problems and concerns that we have out there right now. The aging workforce, there is a noticeable gap in the age profile on site. You will see that most certainly on turnaround events. It still amazes me that upper tier COMAH sites in hazardous industries are still not using the correct methods of applying torque to these fasteners. They use uncontrolled methods and bad practice. Spanners, flogging spanners, impact wrenches, scaffolding poles. I think we've all seen that at some point, surely. And that is a worry. And ultimately, human error plays a massive part in all of this. And in terms of incompetent personnel, we are seeing a worrying number of issues and concerns. And I'm a little bit old-fashioned here in the fact that if you look at time itself, particularly from the 1970s to 2024, the mechanical trades, the coded welders, the instrument and electrical personnel, historically, the standards have always been maintained. They've always been high. Welders are forever, coded welders are forever tested, for example. The complex requirements for electrical personnel and instrumentation guys, these are high level sort of qualifications that, even though they're not mandatory, I think I've got that right within the electrical sort of instrumentation world. Even though they're not mandatory, it seems that industry is pushing these competency standards. And mechanically, for those of you that are old enough, you would remember probably the trade tests that we used throughout our industries. But I've not seen that for probably at least a decade now. So collectively, by not ensuring that competency standards are maintained within the mechanical sort of world, we've taken our foot off the ball really, and therefore our competency standards have dropped. And I'm not saying there are competency issues relating to the world of welding and electrical, but we really don't see the same as we are seeing within the mechanical sort of world. So what does the future hold then? Well, I mean, there's lots of discussion, I guess, about, we don't have a crystal ball, as you can see there, but there's lots of discussion. And I've been to several seminars now with IMechE where the industrial clusters in the UK, for example, are talking about these fantastic and massive projects, for the hydrogen network and carbon capture, etc. And the one thing that's always in the back of my mind is that, yes, they are probably the biggest thing to happen since the Industrial Revolution. But who's going to be building all this? Who's going to be welding all that pipe work? And who's going to be installing all those bolted joints? Because we really are struggling right now. So what does the future hold? Well, we know that renewables are becoming the focus of our future energy requirements. But we obviously have to recognise that oil, gas, petrochemical and chemical sites are still going to be with us for some time, obviously. There is a requirement for emission reduction, and that's been quite evident over the last 5 to 10 years, certainly. A big problem that we have is aging assets. We have to maintain our older sites. Things are not getting easy out there. The UK workforce will get smaller. What I will say is, ironically, I guess the labour pool is actually growing at the moment, but it's the competency levels of the labour pool that's shrinking, and that is a big concern. Large turnarounds within our oil and gas and chemical industries will need to be managed in terms of competency. And I do remember the days where most of the asset owners would kind of talk to each other and stagger their maintenance outages, throughout the calendar year. And what I'm finding is, certainly over the last 2 to 3 years, we are seeing a lot of doubling up and more of large turnaround events all happening simultaneously at the same time. So the labour pool really is stretched, and we are certainly seeing the effects of that right now. I've got that on there. Black is the new green. So there's two things here that's that I was thinking of, in the fact that I keep hearing this term, green skills, and to me, there's no such thing as green skills. It's skills. That's what they are. They are skills, and they're skills that are required for the incoming sort of green industries, etc. But we cannot build and operate these future sort of projects and industries without the old term, if you remember it, the black trades, if you like. People have to fabricate and correctly install all these structures, etc. So black. I've got this phrase: "Black is the new green." I think that's quite apt, actually. So, just to summarize, and thanks for sticking with me on this, everyone. Just to summarize, knowledge is king. Understand the requirements and follow the joint integrity standards and guidelines set out for our process industries. Control, well, introduce, if you already haven't got it, introduce a robust joint integrity process that includes things like flange tagging, third-party inspection. Record the data and learn from the data. If you're finding bad things on site, do not sweep it under the carpet. Learn from it so that you make things better. It's almost like a quality program, if you like. Record keeping is key. It's important to look back and to collect that data. It will give you trends. It will give you information that, if it's used correctly, can improve the situation on your site. We have to raise the bar. Joint integrity qualifications and onboarding standards, not just for your own personnel on site, but for the contractors coming on site. What I will say, and again, I won't name any names, but several of our clients have taken the leap of faith, if you like, and they've insisted that anyone coming through the gate on their site has to have one of the 3 qualifications I mentioned earlier on, for example, as a minimum. And to back that up, what experience have they had, etc., and what's their background, and so forth. Those qualifications in themselves do not make somebody competent, but what it does, it gives a level of it gives a level of competency, if you like, which will certainly please, I would imagine, some of the asset owners, because at the moment we don't know who's coming onto site. That's the problem. Invest in the future. I'm kind of stating the obvious there, but apprenticeships. We luckily train a number of apprentices, mechanical apprentices, across various different sort of sectors, and it's always encouraging to see that investment. We need more of that investment, in my eyes. The use of sorry, if we just go back one. The use of controlled bolting methods, for example, the use of torque wrenches, torque data, lubrication of bolts. All this kind of good stuff, this best practice that should be used at all times, and it never stops there. Even there's no sort of utopia, if you like. We strive for the best, but it's a continuous improvement. It never ends. That image that you see there is a very striking image. Sorry, a very striking image. It sums up what we are trying to achieve. We are trying to achieve loss of primary containment. We are trying to achieve, a minimum level of accidents, of incidents, of environmental concerns, etc., of fatalities, for example. And I'm just going to leave these names there because we kind of discussed during our training sessions, Bhopal, for example, it's the 40th anniversary of the Bhopal disaster, the largest single worst ever disaster in our process industry. Flixborough, that was sort of instilled in me as an apprentice with BP, what happened in Flixborough. Buncefield, Seveso, Piper Alpha, it's 36 years since Piper Alpha. I'm not saying all these were directly relating to mechanical joint integrity because they weren't. But what I'm saying is that these were very important milestones in our process industries, and our standards and our guidelines changed accordingly to these disasters. It's a sad state of affairs, but when industry changes, it tends to change after there's been certainly fatalities in our industry. And for me, on a personal note, what I will say is that back in 2019, I did a compliance audit on a chemical site. It wasn't in the UK, and it was quite a damning report of what we found out on site. And we gave our recommendations and they were ignored. And I found out last year that earlier on last year, I think it was, there was an explosion on site and there were several fatalities. And the root cause were all those things that we brought up during that audit, if you like. And that really hit home to me because that was a clear case of not listening to what needed to be done. And, sadly, people lost their lives. We don't want to see accidents and incidents. It's a massive subject. I could talk all week long on this, Murat, but I'm not. I think my time is up. I just want to thank everyone for, just listening to me. And thanks again, Murat, for the introduction, etc. So I'll leave it there, I think, Murat.
Thank you very much, Chris. It's been a very insightful event, and the talk is sort of speaking to my heart as well, dealing with a lot of bolted joints myself in different applications. I won't start with my own questions. I will actually start with the audience here. I've got a question from Christopher Hertz to start with. He's saying he's working with a client looking to define what's a short bolt, and he's saying opinions sort of differ. We will probably settle on 2 exposed full threads as the minimum. Do you have any views on this?
Yeah, it's a good question. I mean, the general guidance is that 2 to 3 threads, protruding through the nut would be the preferred, I'll say. However, I know where he's coming from on this. There are some sites out there that will accept what they interpret as flush, which, okay, you could put a straight edge across the end of that, and in fact, you'll find that there's a kind of no man's land, one thread where you've got that taper, if you like, on the stud, etc., where you don't have full engagement. So I think it's it seems to be that there are sites that are differing, I think, on this, but I know exactly where he's coming from. For me, 2 to 3 threads, you have to have, if we said that every time if we said that flush is acceptable, before you look around, there's going to be 2 threads under or 3 threads under. So let's try and keep it to 2 to 3 threads protruding through the nut, I think, is the best.
Yeah, my sort of expectation for that is as long as like you lose 1 thread engagement, you're almost increasing the stress on the thread for about 30%, maybe even more actually. So the first thread takes a lot of pressure, doesn't it?
Yeah.
Okay, I will continue with Ilkin Aliyev's question here. He is saying, what's the ultimate root cause, not immediate cause, of these defects you mentioned? Any common denominator? Is there any sort of competency, procedural discipline, lack of oversight, supervision, cost and schedule, or pressures? What do you think? And before I even ask you that question, Adam Atkinson sort of replied to that in response. I guess he's sort of suggesting lack of ownership, perhaps he would say is the root cause for this. Who's going to update the specs? Who is going to say, I want to change the way we have been doing things for years and rock the boat, etc. So what are your thoughts around this, Chris?
I think Adam is spot on, actually. Yeah, well done, Adam. It's the answers are so varied. There's not one single answer. It is so many things. There's a competency concern. There's the attitude and the culture of an organization. There's a reluctancy to change. There really are so many answers to this. It's impossible to just pinpoint it on one thing, I think, you know.
Yeah. Because it's mainly to do with the competency umbrella, isn't it, really? How do we ensure that competency? How do we make sure people actually do what they are trained on?
Yeah, and they say the proof of the pudding is in the eating, right? And just to give you an example, one of our clients has a defect rate during their turnaround of about 1%, 2% maximum, and that's saying that 2% of all those flanges that were inspected, something was wrong. We have, or I know of, other assets in the UK that are as high as 10%, 14%. And when you really look at it, it's all to do with the culture of that organization. If things come from the top and are cascaded down to everyone, and everyone is on board with this and they can see the reasons for it, generally things work far better and simpler than an organization that doesn't address it in that manner. There's a lot of pushback, and that causes problems as well on site. Ultimately, you look at that screen there, we do not want a repeat of any explosion, any loss of life.
Yeah.
Ultimately, that's what this is all about, is preventing loss of primary containment. Nothing more, nothing less.
Yes,
yeah.
There is a lot to do with the actual leadership of the company and drive it down from the top to bottom. But safety is everybody's responsibility from bottom to top as well, isn't it?
Of course, yeah, absolutely.
Okay, I will probably slightly change the subject with Richard Hellebrand's sort of comment, really. He is saying he audits upper tier Seveso, COMAH chemical plants in Europe, and the standard bolted joints is generally good, correct gaskets, fasteners, straight pace, torque values, certification and competency, etc. However, he still finds examples like you showed, really, and says like we have to train graduate engineers about the need to get it right the first time. So that's a comment from Richard. I will actually, if you have anything to add to that, Chris, you feel free to do so.
No, I think that's a very good point. I think, it's exposing perhaps graduate engineers to the realities, I think, of what's happening on site. I think that's a really good point, I think. Yeah, definitely, most certainly.
Good. I will carry on. Another question from Gary Milne. Why do you think some COMAH sites do not have basic SOPs, standard operating procedures, for flange assembly? What would you say?
Gary, that's an excellent question. Wow. If I knew the answer, I think I'd be a rich man. I genuinely do not know, because what's interesting to me is that everything I've just briefly discussed over the last sort of like 45 minutes, about the standards, the guidelines, everything is available, everything is out there. The guidance documentation is there, and I lose the will to live sometimes when I hear of these large, massive blue chip organizations that for some reason don't have certain things in place. It is maybe a cultural thing again, perhaps, Gary. I don't know. It's very interesting to see that, and it is sad to see that. So it's a really good point, actually, but I don't think I can answer it sufficiently, I think.
Yes, I think complacency sort of creeps in over time as well. But I think it is the culture mainly at the end of the day.
Yeah, I think what I will say is this, though. I think nobody wants to see an accident or a disaster.
No.
But if you look through history, I guarantee you, if something happens, industry will change, or owner operators and asset owners will change their views quite sharpish. It's a sad state of affairs,
It is, until there is a catastrophe, not much changes really. But when that happens, everything changes very swiftly, very sharply. Nobody cares how much they really spent on it either in that case. Okay, I will carry on with Sadiq Hussein's question, I guess. Given the current climate where engineers change industry and job roles more often than before, what kind of impact has this had?
Yeah, I think it's having a big impact. I think if you look at, I'm not sure where the statistics come from, but if you look at the stats for those that are, going into degree level, um, engineering courses, there's quite a high percentage of people that sort of shift sort of halfway through, or even when they finish, from being in that sort of mechanical engineering role into, finance, for example. We're losing people. I think it's a cultural thing as well, and I think it starts at school level. I think it starts at STEM. What is there to encourage young people into engineering? What is there to encourage people to work in the chemical industry or an oil refinery? Um, it's really difficult, and I speak to a lot of young people, training center, and it's that I think culturally everyone wants to be in front of a laptop or an iPhone these days, and we need more people that are encouraged to. It's a great industry. It's a fantastic industry. To be a tradesman or an engineer is a fantastic thing. But I think we need to sort of advertise that it's actually it's a well-paid, can be a well-paid career, for example. It's
Yeah.
exciting. And if you look historically, engineers have changed the shape of our industries throughout time immemorial, really. So I think we need to really shout about it more, perhaps, I think.
We do. I think I agree. I agree. Time is getting short, but I will carry on the last two questions here, or comments, I should say. Question from James King, I believe, if I got the name right. Does the UK COMAH industry as a whole have an understanding of joint failure rate, such as leaks or confirmed defective joints prior to startup, or have targets for what an allowable failure rate really is? He's saying he's a railway engineer and want to compare how different industries approach the management of defects, really. What do you think?
Well, I would say and this is just me saying this. I think generally, I don't think they are fully aware, and I don't think they've got the data because there are still asset owners out there who are not recording data. So post turnaround, when they start the plant up and they have a leak-free startup, everyone's really happy and everyone goes down the pub for a pint, etc., to celebrate, and that's it. But we need the data that's been taken during that turnaround event. Because yes, you did have a leak-free startup and there were 5,000 flanges inspected, but you know what? 12% of all those flanges failed initial QA. And that's the important information that we are missing, because that information paints a picture of what is happening at the workplace. When you've got people that are not installing a gasket and yet are still making a 4-bolt flange, or over torquing or whatever it might be, loose bolts, it's that level of detail that we really, really need. And so I think this has been great today. I've really enjoyed doing it, actually, and I think the seminar that we had at the earlier part of the year was excellent. I think the ball is now rolling, and I think industry is aware of all this. But it's great that IMechE you're taking this forward, I think, and really pushing the agenda. So I think we really need to shout about it more, to be honest with you. I believe.
And thank you for kicking it all, Chris, really, and sharing your knowledge here as well. I think you raised a lot of questions here. People are interested thanks to you. I will go on with Patrick Ferguson. I know of Chris from Croydon refinery days and try and take all of those learnings with me to other places that I work. Joint integrity seems so simple on the face, but frustrating how often some companies still seem to be getting it wrong. Simple things like bolt lengths set on the isometric by the designer 18 months ago, but not followed up and checked in construction stage. There are some good lessons learned about checking and checking again at every point of the design and construction process. By the time you get to construction, it can be sort of too late to fix some of these issues, really. I guess that's a comment from Patrick, which I find
great, Patrick.
true.
And I will say, Corridon sadly is no longer with us, but what a fantastic refinery that was to work. And safety and process safety was always high on the agenda. And all those years ago, 20, 25 years ago, there was a joint integrity procedure on site, for example. They were really taking the lead in many ways. We need more of that.
Mm-hmm. Excellent. I mean, time is really pressing on. I've got a couple of questions left here. I don't probably have the time to actually go through them all. I will just ask one last question perhaps and then wrap up the event if that's okay. I'm so sorry for everyone that I couldn't get to answer all the questions, but I will pass them through Chris. Maybe he will come back to you afterwards.
Yeah, sure, yeah.
Andrew Lang is asking, is it acceptable to have a competent supervisor working with a team of riggers when making up joints with torque wrenches, or does the whole team need to be competent? Interesting.
So, sorry, can you say that a bit again?
So is it acceptable to have a competent supervisor working with a team of riggers who know nothing probably, or not as competent, when working, making up these joints with torque wrenches? So is it okay to just have one person in the team, or
No.
do you need to get the whole team really trained up?
The whole team, absolutely. Absolutely. So for example, you take process operators. You know, for many, many years, process operators were never given any formal mechanical training, and yet we allow them to, you know, take off blanks and put blanks back on and work on filters and sampling points, for example. We are seeing a shift change now where we've seen a lot of process operators come on training courses, which I think is a great thing. But anyone, I mean, the standards will say anyone that's responsible for making that bolted joint has to prove competency. It doesn't matter if you're a rigger or anything else.
Well, I think this is all the time we have got for. I've got some wrap-up sessions, but I'd like everybody to please raise your hands, clap virtually or whatever you would like to do, because I really loved my discussion with Chris today. Thank you so much, Chris.
Yeah, thank you. It's been a pleasure. Thanks.
There are a couple of slides left, Chris. If you don't mind just going through them quickly, I will just share with the people to how to sort of watch the previous recordings of other events we have organized, but I will get this event added to this Process Industries playlist. If you could move on to the next one, Chris. There is sort of upcoming events as well. There is Thermal Energy Storage Solutions on the 6th of November, about the same time. There is another one to do with the hot reality, living in a 50 degrees C world. There is actually another event we recently published, which I couldn't add to this presentation, to do with the Energy Institute again, their process safety management framework. I'm going to put those things in the chat for you to have a look at in your own time, but I'm looking forward to all your feedback, really. If you have anything you would like to share with me, please email me and I will issue the CPD certificates to all attendees. And I will actually share the slides with all the registrations. So thank you all very much again and have a great day. Thank you again, Chris. Take care.
Thank you. Thank you. Bye-bye. Thank you, Murat.
Cheers.